42,000 years ago, long after modern humans had already spread across Asia, something hit what is now southern Korea with enough force to melt rock, collapse mountains inward, and carve a 7-kilometer wide crater into the earth. It didn't just leave a scar, it created a lake, drove a hydrothermal system, and built a completely new environment from scratch. Today, that entire event is hidden beneath farmland and sediment, its violence erased from the surface, but preserved perfectly underground in what is now known as the Hapcheon impact crater. In a fraction of a second, something moving faster than sound itself struck the earth, so fast that the rock beneath it didn't behave like rock at all, but like a fluid under extreme pressure. What followed wasn't just an explosion, it was the sudden creation of a structure so large, so violent, that it would reshape the land, generate its own lake, its own hydrothermal system, and even its own biological environment. And almost no one today realizes that it happened here, in what now looks like an ordinary basin. And it tells the story of a collision that unfolded in seconds, but whose consequences lasted tens of thousands of years. When the impact hit, the process began with what geologists call the contact and compression stage. But that sterile phase doesn't capture what really happened. The moment of impact generated shockwaves that propagated through the ground at immense speeds, compressing the rock beneath to pressures far beyond anything found naturally at Earth's surface. The energy was so intense that rock near the point of impact didn't just fracture, it melted and in places, vaporized. According to the studies, this process created impact melt rocks and glass-bearing breccias, a chaotic mix of molten material and shattered fragments formed in an instant. At the same time, the force of the collision drove material both downward and outward, excavating a transient cavity far larger than the object that created it. This excavation stage was explosive in every sense of the word. Rock was ejected at velocities reaching hundreds of meters per second, blasting beyond the rim of the forming crater. Some of it fell back almost instantly, raining down as fallback debris. Other material travelled farther, carrying with it fragments of the pre-impact landscape, plants, soil, and sediments that would later complicate the geological record. The studies describe how organic material from the surface was ripped up and redistributed, mixing older carbon into the newly formed crater deposits. Even in the chaos of impact, the seeds of later geological puzzles were already being sown. But the crater we see today is not the crater that formed in those first seconds. The initial cavity was deeper, likely more than 400 meters, and structurally unstable. Almost immediately, gravity began to reshape it. The walls of the crater collapsed inward, sliding along faults that developed in concentric patterns around the impact site. This collapse stage transformed the transient cavity into a more stable structure, widening the crater and forming the complex architecture that defines it today. Beneath the surface, rock that had been compressed during impact rebounded upward, forming a central uplift, one of the defining characteristics of a complex crater. Although this uplift is now buried beneath sediment, geophysical and core data reveal that it still exists, a hidden remnant of the enormous forces released during the impact. What makes Hapcheon particularly fascinating is that this violent event didn't just destroy, it created. As the crater stabilized, it formed a natural basin, and that basin began to fill with water. The studies show that this happened rapidly. Sedimentary evidence indicates a sharp transition from coarse impact-derived deposits to finely laminated lake sediments, suggesting that water flooded the crater quickly, forming a deep lake with little transitional shoreline. This wasn't a gradual process. It was more like a sudden appearance of a new environment, isolated from the surrounding landscape. Inside this newly formed lake, the story shifted from catastrophe to transformation. The heat generated by the impact didn't dissipate immediately. Instead, it drove hydrothermal circulation within the crater. Water percolated through fractured rock, heated by residual energy from the impact, and rose back toward the surface carrying dissolved minerals. Evidence for this comes from both geochemical signatures and mineralogical data. Early lake sediments show elevated calcite content, up to 13% in some layers, indicating that the water was chemically saturated and influenced by hydrothermal processes. At the same time, rare earth element patterns and isotopic signatures in stromatolites point to hydrothermal input and even traces of meteoritic material within the system. This hydrothermal activity turned the crater into something unexpected, a biological niche. In the quiet margins of the crater lake, microbial communities began to grow, forming stromatolites. These layered structures, built by microbial mats trapping and binding sediment, are among the oldest forms of life on Earth. Their presence in Hapcheon suggests that impact craters, far from being sterile scars, can become habitats. The conditions inside the crater, warm water, mineral-rich fluids, and isolation from external disturbances created an environment where life could not only survive, but thrive. The studies even suggest that similar environments in Earth's deep past may have acted as oxygen oases, contributing to the development of early life. Yet beneath this calm surface, the crater was anything but stable. The sedimentary record reveals a landscape in constant adjustment. Early lake sediments are riddled with microfaults, tiny fractures that formed as the basin continued to settle and compact under its own weight. These faults are not random, they reflect the reactivation of structures formed during the impact itself, as sediment loading and gravitational forces cause the crater to shift and deform. In some layers, the sediments are folded, contorted, and disrupted, evidence of slumping events where large sections of the crater wall collapsed into the lake. These slumping events were not isolated, they occurred repeatedly, especially in the early stages of the crater's evolution. The studies describe sequences of deposits that record these events in detail: lode structures, slump deposits, graded layers of sand and silt, and fine clay caps that settled slowly through the water column. Each sequence represents a sudden disturbance, material collapsing from the crater rim, sliding into the lake, and then settling out in characteristic pattern. These events may have been triggered by ongoing instability, seismic activity, or the gradual weakening of the crater walls. Over time, the frequency of these disturbances decreased. The crater began to stabilize. Sediments accumulated more evenly, forming laminated layers that record a quieter period in the lake's history. But this stability was temporary. The final chapter of the crater lake was abrupt and dramatic. Instead of slowly transitioning into a wetland, as many lakes do, the Hapcheon lake ended suddenly. The sedimentary record shows a sharp boundary between lake deposits and overlying wetland sediments, with no gradual coarsening or shoreline development. This suggests that the lake drained rapidly, likely due to a collapse of part of the crater rim that allowed water to escape in a sudden outburst. By this point, tens of thousands of years had passed since the impact. The lake had filled with sediment, the hydrothermal system had cooled, and the once deep basin had transformed into a shallower environment. Eventually, it became the landscape we see today, a basin surrounded by mountains, its violent origins hidden beneath layers of sediment. What's striking about Hapcheon is how complete this story is. The crater preserves not just the moment of impact, but the entire sequence of events that followed: the immediate destruction, the formation of a complex structure, the development of a lake, the rise of a hydrothermal system, the emergence of life, and the eventual infilling and collapse of the basin. Each stage is recorded in the rocks, from the chaotic breccias at the base to the finely layered sediments above. And yet, despite all of this, the crater is almost invisible. From the surface, it looks like a normal basin. There are no towering rims or dramatic central peaks. The defining features of the impact are buried, smoothed out by time and sedimentation. It's only through drilling, geophysical surveys, and careful analysis that the true nature of the structure becomes clear. This is what makes Hapcheon so compelling. It's not just an impact crater, it's a demonstration that some of the most extreme events in Earth's history can leave behind landscapes that appear completely ordinary. Beneath the surface, however, the evidence remains: shocked minerals, impact breccias, faulted structures, and a sedimentary record that tells the story of a collision that changed everything in an instant. I hope you found this as interesting as I did, and as always, thanks for watching. Before I end this video, I'd like to give a big shout out to my Patreon and YouTube members. Thank you so much to everyone that helps to support this channel.